now our next speaker is James Crompton, a professor of practice in the Petroleum Engineering Department. Jim retired from Chevron in 2013 after almost 37 years with the major international oil and gas company. After moving from Houston to Colorado Springs, Colorado, Jim established the Reflections Data Consulting, LLC, to continue his work in the area of data management and analytics for exploration and production industry. Jim graduated from the Colorado School of Mines with a BS in geophysical engineering in 1974 and an MS in geophysics in 1976 before joining Chevron in Denver, Colorado. He later earned an MBA degree in 1996 from Our Lady of the Lake University in San Antonio, Texas. Starting January of 2018, Jim teaches a new undergraduate level course in petroleum data analytics in the Petroleum Engineering Department at the Colorado School of Mines. The course is the capstone for the data analytics minor in petroleum engineering. A continuing education workshop on the same topic with Professor Elio Dean in May is offered through the Colorado School of Mines. His current project is to develop 2 graduate online courses in data analytics based on the approach developed in this capstone program. So take it away, Jim.
Well, thank you, everyone. I want to, again, just kind of a voice check and see that if you could see my screen and hear my voice on all this.
Yes, I can hear you.
Okay, well, I'll get going. I am usually the oldest person in the room, and while there's a few veterans out there that I heard about in your introductions, still think I've got you by a couple of years. Someone talked about their second career. This is actually, I consider my third career in terms of becoming a professor of practice at the School of Mines. I'm a 5th generation Colorado guy. One of my family myths is, we don't know if this is true, it hadn't been fact checked by Twitter yet, but one of my ancestors was the first school teacher in the territory of Colorado. And when the winter he was teaching, and they got a couple of Kit Carson's children. Kit Carson, the famous Western pioneer and the early New Mexico governor, actually was hunting buffalo for the Bents at Bents Fort near La Junta, Colorado in Southeast in the 1870s. So I got deep, deep Colorado roots, which is one of the reasons I came back. Although, most of my professional career with Chevron was actually in Texas or Louisiana with a short stay in the UK for a while. What I'm going to try to talk to you about is something called the digital oil field. And you may have heard of this or you may not. It really is, and I understand from your introductions, there's an awful lot of you that spend a lot of time in the oil field. So, what's changed or what hasn't changed. And I think one of the important elements of the digital oil field is that we do have some operators that are still operating the way they did when the well was drilled in 1970s, 1980s, or even before that in some places. But an awful lot of newer field applications, newer drilling wells, we're using a lot more data. We're using a lot more automation. And Jennifer, Dr. Miss Kimmons talked a lot about, some of the data that we're recording. Fiber optics records just orders of magnitude more information than we ever had before about the completion operations. The microseismic that she talked about, lots and lots of data are being recorded. So, the challenge here is, what's the use of all of that data? Why are we recording it? And what can we do because we have the operators, the oilfield service companies, the contractors, and even in a lot of cases, the sharing data with the regulators through the permitting process. Everyone has a lot more data to understand what is really going on in the field. So this idea of the digital oil field started, again, Dr. Miss Kimmons talked about hydraulic fracturing isn't new, but the digital oil field is probably at least 20 years old. And at the time, you can go back even before that and find that disciplines such as geophysics, petrophysics with their well logs, reservoir simulation, characterization, sort of things, you'd use lots of data. And all the data that we have, we would put together, we would take it into our data centers, we would crunch it, and we would try to come up with models. And the whole purpose of the model is not only to predict, but to understand what is happening now, why is it happening now, but to then the model, then we can play it forward in time, and we can begin to understand what might happen and control the future. The students that I have in my classes, I'm saying that the new job of a petroleum engineer is not only to design a good well or a field plan, and not only to monitor how well your plan is being executed, but it's to understand what's going to happen. And management is now asking them questions that they have to, put their wizard hat on and become future tellers. So this digital oil field is led because we have an increased amount of data. There's an increased number and variety of sensors that are out there. Most of them are on the surface. They're on the wellhead. They're on critical pieces of equipment, a pump, a compressor, or whatever. And then you also have, the field automation, the SCADA systems that are, again, controlling information. They're usually rather coarse in terms of just measuring pressure or temperature and maybe shutting down critical equipment or wells if that gets too high. But now increasingly, the equipment has an awful lot of sensors on them as well, and they can actually not only record vibration and other sorts of information about them, they can actually do something about it so that they can operate smarter. And we've got an increased amount of information in all different forms. Sometimes the term big data comes around. Well, that's not just a lot more data in terms of volumes, which, we need bigger data centers in order to try to store all of that. It's an increase in the different types of data, documents, historical information, even financial transactions and, sales tickets and all the rest of that, procurement, documents where we're ordering equipment. But it is the variety and the velocity, because now we can hook up from the field to the office, and we can get information from the SCADA system that instead of 2 months old, maybe 2 hours old. And so we have a velocity impact, we have a volume impact, and we have a variety impact of all the things that are going on.
Excuse me, Jim, would you kindly put your presentation into full view? We've had a couple of requests for that.
How about that?
Perfect. Thank you so much.
Sorry about that. And also one of the things, just like Dr. Miskimmons, I'm glad to answer questions through chat, but that'll certainly be part of the panel as well. So whenever something strikes you, let me know. So now you're not seeing all the other slides. The changes now over the last 2 decades, the first emphasis was a lot on connecting field to office and sharing that information, because we had most of our experts sitting in the office, and it was costly to go out and send them out to the field whenever there was a potential problem. So we wanted to bring the data to the office where the experts were. And that's where our data centers were and where we could crunch our models. And we could, we had an idea here, which was called manage by exception. And what that was is we're not only monitoring what is going on in the field, but we're comparing it against our model-based results. And instead of just being guided by, well, what's the production, what's the temperature, what's the pressure, we're being guided by, is what's happening what we thought was going to happen from our models. And of course, we find the model is always wrong, but often the model is guiding us in useful directions, and we have feedback loops, and we continue to improve the models that we're using. Model of reservoir performance, the model of equipment health, the model of production, which is always that, not just the oil or natural gas, but the water that's coming out of the reservoir. So, in that we're being able to compare those two. And again, it's not really changing so much what we're doing in the field. It's still a very physical process to extract oil out of the ground. But now we have this companion digital view of what is happening. And we can compare the two, and we can even do experiments in our mathematical model before we do it in the field. And we can improve kind of the efficiency. But over the last 2 decades, what we've really done is we have improved the connectivity. There isn't fiber optics between every well site and the rest of it. There are still places where it's hard to get information out of the field and then back to the office, and then from the office back to the mobile worker, the lease operator that's going around in the field, or the maintenance supervisor, or whomever. But we have a greater deal of connectivity around that. The remote decision support centers that you'll find in many operators' offices, or even oilfield service operators. And there's some degree of a remote control of processes. You don't see this onshore as much, but you certainly see it offshore when you have the idea of hurricanes in the Gulf of Mexico, and how long can you certainly want to take the people off the platform as soon as the weather gets bad, but you can still operate remotely for a while until weather gets too bad and you have to shut in. Or maybe the hurricane changes and you can operate continuously during that whole period of time when there's no human beings on the platform. But so this connectivity is an important part of it, and the digital intensity is an important part of this digital oil field. You'll now find an awful lot of petroleum engineers that they spend their day in front of computer screens. The younger ones like that, the older ones don't. The older, or it's not just an age-related thing. Obviously, some people really like working in this sort of environment, and this whole idea of what we've been doing, and we're working from home and working remotely with the office. We can take this data and we can put it in your living room or your bedroom, or we could put it in your truck as you're driving around. So, we're being able to connect people with data wherever they are. You could take it with you if you go around this stuff. So, and it's not only the data is pumped to the operator, the data is pumped to the oilfield service contractor as well, as they're beginning to understand, what's really going on in the field. So you're getting a more realistic surveillance of what is happening in the field, but you're doing it remotely, wherever you might want to be. Well, here's the granddaddy of all of these reservoir remote support centers. And this is in Saudi Arabia. This is the control center for Saudi Aramco in Dhahran in the kingdom. And essentially they have so completely digitized their operation that every well, every critical piece of equipment, every water pumping unit in the entire kingdom, all this data is available at this one site. And of course they spent lots of money to do this. And not everyone is going to go to this extent in order to how to do this, but this is just kind of one extreme of what's possible. Or, if you've got an economic business case for doing all of this stuff, you can build one of these centers if you wish. Well, as Dr. Miskimmon said, a lot of this stuff isn't brand new. I mean, you hear a lot of marketing hype from tech vendors that here's my brand new thing and just buy my kit and you'll be digital. Well, a lot of this, has really come from decades of experimentation and decades of evolution. The oil companies aren't always known as some of the most rapid adopters of the digital technology, like an Amazon or an Uber or, whatever, kind of technologies. We may not be going as fast as e-commerce or e-banking or a lot of other kind of areas. But so there is a conservative nature to make sure what you put in is safe, what you put in adds economic value. And so, the adoption of digital technology has been slower, but it's been more careful and more thoughtful, I think. And the idea of a smart well, I mean, it isn't just fiber optics down a well to gather information like Dr. Miskimmons was talking about, but it's actually something where I can get the information, I can understand what's happening in the reservoir. In this case, maybe I'm water flooding a reservoir, and maybe I'm monitoring the water oil ratio. And maybe I realize in sand A, all of a sudden my water cut is 80%, 90%. And what I really need to do is stop injecting water into that reservoir but I need to close it off. And instead of doing a well intervention, I'll just use one of these actuators with these moving sleeves, and I'll shut off zone A. And then I'll go around and with my injector producer pair or pattern, I will start putting water in zone B or zone C. And I can essentially manage the water that would be produced by keeping it in the reservoir, by not producing it in the first place. So that is some of the economic benefit of the digital information that's coming back. And we could do this in more real time. I'm not waiting for years to recognize that my GOR or my water cut is growing. I could do this on a weeks or months sort of basis. And in doing that, again, economic value, produce less water that I can't sell, produce more crude oil that I can. Well, as we're moving into this now, and of course, Dr. Miskimmons had a bunch of cool pictures about unconventional reservoirs, and here's mine. Essentially almost everything from the drilling aspect of this, essentially we are drilling a well that may be, 10,000 foot vertical, and then we kind of turn it horizontally, and we may drill for another, 2 miles. It's 3 miles, I think, have been some of them the greatest extent. Of course, we have to understand where our lease limits are, and we can only drill to the end of where we're legally allowed to produce. But the accuracy and the precision of the drilling in these sort of cases is critical. And how do we do that? Well, we do it with more data available, and we have the measurement while drilling, MWD, things that we just said of maybe a couple drilling strands, above the drill bit. And we have LWD, logging while drilling units. So help us understand the rock we are drilling through. And directional drilling has become one that has really been advanced because of digital oil field sort of technology and advances. Well, we're still willing and waiting to drill the perfect well, but we're drilling better wells. And the drilling learning curve, or often called the drilling factory, essentially we are learning from the last well to drill the next well better. And we're doing it through gathering a lot of information. And we get that information to go into our computer models to produce better designs and then produce better, kind of results as you go through this. And that's kind of expected. And operators depend on contractors getting smarter, and smarter means more efficient, less cost. And we're also comparing drilling to completions, to production, to reservoir management across the entire value chain. We are able to not only figure out not just drilling a better well, a cheaper, faster well. I want to drill a well and I want to hydraulically frack it in a way that I produce more oil. And we know when these unconventional wells, they decline very, very quickly. And within a matter of months, you're putting it on artificial lift. And even that, still you have decline curves that are 3 or 4 times that of a conventional well. So do you have to keep drilling all the time in order to keep up your production? Can you look at these wells and have refrac candidates? An awful lot of it, again, has to do with the information that we are collecting, which allows us to build better models, which allows us to go in and have a more efficient and effective and hopefully safer, kind of operation, and one that has a lesser impact on the environment as well. Because clearly that's important to operators, that's important to the industry, it's important to the community, and we were getting required more and more to operate in a cleaner way. Well, Jennifer showed you a picture of a medium-sized frac job. Well, this may be one of the big ones. And essentially, we're talking about the very high pressures in order to break rock, deep down and into the earth. So even if you look at this from the digital oil perspective, so the operator, the operations manager here sees a tremendous logistical challenge. How many truck loads does it take to bring all of this equipment to the site? What are we doing to the roads that we're driving on? I mean, clearly there's some areas, West Texas, Western Pennsylvania, and in other places where, we are wearing out local county roads. And we have to, how can we do this more efficiently? It's one of the reasons that led to kind of pad drilling and the rest of it, where we, instead of drilling one well on this site, we may drill 8, 12, 16 wells on this site and kind of not disturb the equipment. So this almost becomes a logistical challenge too, so that we're not only drilling a good well and fracking a good well, producing it for as long as we can, we're actually, trying to figure out how to do all of this massive operation more efficiently. And that leads to, you see all this equipment, there's probably a dozen different contractors that are working for the operator on the site, and the coordination from the logistical aspect is another challenge. And even road traffic, and even directing well inspection, lease operators, and drilling well intervention crews. It has become a on the surface ground logistical challenge for our operators. Well, we want to end up with something like this. We have hopefully a minimal disturbance of the land surface with the maximum number of wells that we can drill. And while it looks like we may be only operating on a couple of acres of land here where we've disturbed, we may be going out and with the reach of the horizontal wells and being able to tap the potential of a lease that may be several sections or more, when we talk about thinking about this not just as a single well, but as a whole cube of rock that we're trying to maximize the potential for, yet minimize the cost and minimize the impact we have on the environment. Well, several of you talked about drone programs, and I think that's one of the cool things that's happening nowadays as we go through this. And it really depends on the regulations and inspections on where you can use drones, but they're increasingly becoming an augmenting another set of human eyes in places where maybe humans don't want to go. And in this particular case, climbing down on a rope and looking under the some of these decks on a offshore production platform for fatigue and corrosion and the rest of that. I'd much rather fly a drone and have that being my eyes to try to do these inspections safer and taking people out of harm's way. And yet, I can not only get the visual range of inspection, I can put other sensors on that drone, and I can look at thermal signatures, I can look at chemical signatures, I can learn a lot more and augment the role of the human being through some of this new technology. And regulators, you guys are using it for obvious reasons to improve the efficiency of your inspections. Operators are doing the same thing. This is kind of another good use of the technology plus the human being, leading hopefully to a safer operation. Well, we could take this all the way to the fact of, do we have to have human beings on the platform at all? Offshore kind of example here in the continental shelf of Norway, they're a country that is kind of leading an awful lot of the adaptation of a lot of these technologies, but this Valdemar platform, which is not in deep water, it's in just medium-sized water, and it's not a super giant field, it's a medium-sized field. But essentially, the operator, and this is this Statoil, or what's now called Equinor, the state oil company of Norway, has essentially taken all of the control functions and facilities off of the platform and brought them on shore. And the human beings come to work at regular office hours, or with different shifts, et cetera, but they are in remote control of the operations from the field. And you're going to see more and more of this offshore, and what's now called minimally manned facility or normally unmanned facilities, that we're starting to take people. And when we take people off, we can take iron off, and we can take capital costs out of operations. Yet still, you have to operate this. And kind of one of the maybe counterintuitive things is the experience we have on these facilities as we can actually operate them safer. And so the safety statistics on all of these things are actually better than the normally manned sort of facilities. And that's been demonstrated in Norway and the UK and Australia and a number of other countries. Well, this isn't brand new. This is the Northwest Shelf of Australia and an offshore gas processing, gas production platform that has been normally unmanned now since, I think, 2008. So we are gaining more and more experience on how to do this. Now, yes, human beings have to visit this platform maybe every couple months to do repair work, maintenance work, maybe a small project or so. But normally in operations, when everything is going as planned, there isn't a human being here. the closest human being to this platform is probably 1,000 kilometers away in Perth, Australia. Well, again, what do we do with all the data? It becomes a challenge in management, in processing, in display, data visualization, in alarming. You know, with all of this information coming in so quickly, we have to figure out very clever, intuitive ways to get the information to the human beings who are making the final decisions. Some decisions are actually not even made by human beings, they're made by automation. And rules that we put into the SCADA system or whatever, the DCS system as we're going through it. But there's a whole new art form about just how do we display all this data. You know, in a sense, the oil company has broken Excel because we have too much data to kind of show. So we have to get very creative about how we display the volumes, the variety, and the velocity of all of this sort of information. This is actually one from Liberty Oilfield Services that operates here in the Rockies. Well, clearly, most of this investment's been made to improve production, to understand and lower operating costs, to try to lower capital expense as we do that, and lower the LOE, the lease operating costs with maybe fewer human beings, you know, as part of the operating, you know, practice in the oil field. But we can extend this to safety, and we can instead extend this to the health of our operators. Taking human beings away from dangerous positions is a real win from the safety sort of perspective. And now it's moving into monitoring the environment. And clearly, most of our field automation systems were really set up to monitor the production practices. We are now augmenting that, again, digital oil field sort of technology, and we're going after the sensors that will look at air quality, that will look at methane emissions, not just the flaring and the venting that the flaring we do on a permitted basis, the venting we may do for a safety kind of upset, but maybe we need to go into a continuous monitoring mode and have a better idea of, you know, the environmental impact on air and water as we go through this. Well, just one example, and there's a number of companies. I don't want to pick out just one in particular, but this is a company in Colorado, Project Canary, that is working with the School of Mines, our Payne Institute, and we're being able to have continuous monitoring, not of just all of the pressure and temperature that we normally look at with our other systems, but air quality. And these sensor packages, platforms that we have out there, essentially through Internet of Things technology, we can connect them to the cloud, we can send them back to wherever the data center is, we can do our processing on them, and we can essentially do a much better and quicker job of understanding where there might be leaks. And oftentimes, it might be just a very simple equipment repair, or it might be a change in work practices of how, you know, you're loading up oil into a truck to take it away. It is doing all of that so that we can get cleaner, and we can demonstrate to the community that we are indeed, you know, paying of close attention to this aspect of the operations. Well, the oil and gas industry today isn't inventing most of this technology. It's a challenge of adaptation rather than invention. And a lot of this technology is coming from everywhere. Augmented reality, from gaming sorts of things. You talk about one of the guys playing too many video games. We're now playing video games in the oil field about operating procedures. We're having to have connectivity all around the facility. We're trying to bring that information back to the operator, the connected worker, or even having, you know, the algorithms be a virtual assistant, Siri for the oil field, kind of helping us to remember all of the important things that are going on. Well, here's the video games that we play in the oil field. And fortunately, we are now designing most of our facilities digitally from the beginning. And so all we have to do is take those drawings through CAD/CAM software, move them into a gaming sort of platform, and all of a sudden we can do training. Our avatar can train on a new facility as it's being built. Or essentially we can go in and we can look at these digital twin models that they're called, and essentially understand how to improve production. One of the things that Colorado School of Mines is really talking about is the next generation workforce, the next generation of petroleum engineers. And what we are doing, what we didn't do back when I was in school, is this digital literacy is becoming a very important part of what we teach. The students that I teach are mostly in seniors and graduate students, but they are already proficient in statistics and in advanced analytics. They all have Python programming courses, and essentially, they are all as comfortable with the digital side of this industry as they are with the physics side that are taught in the traditional sort of courses. And now we're reaching out online to get to experienced engineers that maybe they missed some of these classes when they were in school, and now they can get them through online graduate certificates. But we have a lot of challenges. This isn't easy. The integration of all of this information, the visualization is not easy. And the whole idea of how does the human work with the machine, work with these computer models, and how do we work together, a lot more cooperatively and a lot more efficiently as we go through this. Some people are worried about is artificial intelligence taking over the world? Well, the answer is it is, and we're going to have to learn how to deal with it. And we're going to have to, people talk about artificial intelligence or machine learning or 100 other kind of acronym sort of things. How do we work with that? These are all new tools that are part of our business. Well, through natural language processing, the rest of it, we're going to be talking to this technology, not typing it on our keyboards. So AI is now a co-worker, not just a tool. And these digital twins, these models of our facility, they're becoming richer and richer. So it starts with a piece of equipment. Then it goes to an entire wellbore and processing assembly on the surface. Then it extends to the wellbore itself and all the things happening in it. And finally to the earth, in the subsurface, the reservoir itself. And a lot of this, we don't understand the physics completely, but we have an awful lot of data, so we can build models from the data itself. And it's physics and statistics that are building these models that are increasingly useful in how we are managing the digital oil field. So I'll stop there. Questions now or questions in the panel? Linda, I'll let you kind of moderate how this goes now.
All right, so let's go ahead and take questions verbally. If anybody would like to propose a question to Jim at this time. Okay, how about a chat if you don't feel like putting your voice on the record?
It's the old saying, if you can't dazzle them with your brilliance, you baffle them with your bullshit. So I guess I succeeded in one or the other way.
Jim, this is Jason from North Dakota. What would you suggest to, say, high school students that what coursework would you recommend that they get into in order to be proficient with the information that you're promoting?
That's a really good question. There's a couple of things that I think we're trying to do in the Petroleum Engineering Department. And we've got a lot of support, not only from Dr. Miskimmons, who's our department head, but her bosses within the school is, one, it's a physics and digital literacy challenge. Mines offers a data analytics minor within petroleum engineering, in which case they have to take courses in computer science as well as in statistics, and then getting into a couple of advanced courses on we call petroleum data analytics, of how you apply all of this stuff within the traditional physics background. So in terms of if you're aiming as a high school student to get into this, and for your undergraduate degree, I think you have to incorporate a lot of these other sort of courses into your regular physics curriculum. Now, that's hard. So the next step is you have to continue to learn. And, it's why we're reaching out with this online graduate certificate, because, you have to keep learning. And, then you also have to go to work and earn a pay check. So, the whole idea of online learning, lifelong learning, this technology changes so fast that it is very difficult to keep up with. So almost in a sense, you're never finished would be the second, piece of advice I give to that student. The first one is it's digital and physics. The second one is you're never finished learning. And a lot, so all of that, kind of put together is what I have to say is, the technology is not going to stop. And a lot of the technology is going to be very useful in operating cheaper, more effectively, safer, cleaner. We have to bring it all together, and the integration, the complexity is what I think. If anything, is one of the industry big challenges is managing all of the stuff that's coming at us.
Thank you.
Jim, this is Ryan Gross from the EPA. How have you noticed this move to fast bigger data has changed the relationship between the inspectors and the industry? Is there data that's being flowed to the inspectors? Are there ways that the regulators should be changing the way they oversee or the way they write permits to take advantage of this data that you've seen?
Well, the whole idea of the having greater transparency, and data allows us to share data. So I think we're increasingly sharing more and more data, and this will change operators' relationships with regulators as well. So I think you're hitting on a very important point. I mean, right now the industry has started sharing data between field and office. That started 20 years ago, and then we started exchanging data with oilfield suppliers, and that came. We've been doing that for a decade or so. We're sharing data with other partners, essentially in the field, and I think there's the opportunity, and it kind of varies by state and province and country how much data is actually kind of shared. I was fortunate to be part of a study that was sponsored by the National Academy of Sciences about this whole idea. It's mostly about offshore Gulf of Mexico, and the Department of Interior was the one that sponsored it. But essentially, what should this capability be? And I think, in a sense, our whole idea of what data we want to share, what data we want to, in a sense, I'll make a provocative comment here. I think the whole concept of the documents that we exchange through permitting processes will be surpassed. I think you'll have an ability, regulators will have an ability to see more of what's going on right now, not just what I put in my permit a couple months ago. There's a whole issue of trust. There's a whole issue of that you don't want to play gotcha when you see an issue. What is the operator's legal responsibility? What is the contractor's legal responsibility? Regulators, you're driven by what laws are passed by the state and provincial and national governments. It's evolving, but I think there's a whole nother chapter just right around the corner, which will allow us through data transparency, data sharing, to have a much better idea. And maybe your idea of field inspections may change. I mean, you're already thinking about things like drone level inspections, which cover a lot more ground, don't wear out the Ford pickup truck as fast. But I mean, the idea here, if it gets in the whole, this concept of Project Canary, first of all, it's letting the operators know what's really going on with regard to emissions in their field. But then why in some time in the future is that data not shared with the regulator? Why isn't that data shared with the community? The head of Project Canary is actually a former Colorado State Senator, Chris Romer, and he's very conscious of this opportunity that transparency could build to trust, can build to a greater idea that we're all operating on the same page in the same direction. So I think the idea of gathering all this data, we've only begun to start with the whole value of sharing it with different stakeholders.
Are there any agencies that you see that are more forward in this sense, or more leading the way here, or are there places where the industry is seeking for regulators to play more of that role?
Well, I know in Alberta has been a place where it's been working with the industry in a very collaborative way around data sharing and data standards, et cetera. One of our big problems in sharing data with regulators is everybody's got their own standards. Everybody's got their own ask with regard to the permitting processes. And it makes it complex and expensive to have. We don't have one way of doing that. We don't even have one way of calling a well a well. That's the problem. But Alberta has been leading. I think in Colorado, I'll brag about my local state a little bit here with regard to Frac Focus was an initiative that was a government and operator and supplier kind of initiative where there was a great concern about what we were putting in frac fluids, some of the 1% that's not water, and was it dangerous? Did it impact water quality? So Frac Focus was in a way of just for everybody to publish what chemicals were being used in the frac jobs. And it kind of calmed down to a certain extent, not the 10% Dr. Miskimmons talked about that's not going to believe us, but it calmed down others in terms of saying what was the facts. And I think we need to we build trust based on facts is going to move us forward. So I'm sure there's initiatives in most states. There's initiatives within the federal government as well in the U.S. And we're beginning to open this opportunity up. And every regulator is going to have probably a different interest. Methane emissions now are a big one, and that a lot of people are talking about. And so as we gather more data about it, I think then we'll be able to move like we did with the Frac Focus issue around, what chemicals we were putting in the frac fluid.
Jim, we have a question in the chat from Larry.
Let me go to it and see if I can. I'm having, can you read it to me? I'm having a little trouble.
Happy to. From the regulator's perspective, what challenges do inspectors face when there is no one at the well site to communicate with when operated digitally?
Well, that's a good one. Somehow the field inspector has to get connected to that digital environment that the operator has. And, so you're right. If you go there and you want to talk to the field foreman, and the field foreman is back at the regional office, and, and you're there and looking at it, and the telephone is not adequate to share all the information. Today, most of the field workers, the operators will carry a ruggedized tablet around and a smartphone around. And with that, they become connected to all of the information that's being collected and processed, et cetera, around there. I think in a way we're going to move where somehow, to some extent, to some of that information will have to be shared digitally to the regulator, the field inspector too. And you have to be connected. Right now, we've got a wall between the two, and it's probably very uncomfortable. If I was an inspector and I was asking a question, and you can't talk to the rod pump, you have to talk to a human being. Well, maybe in 10 years you will be able to talk to the rod pump, but right now you need to be connected like the lease operator is connected, and getting that digital environment. You may not have to visit sites as often. Of course, you have a regulated kind of a specified sort of time now that you have to, and visual inspections won't go away. They'll just become less common. Maybe the drone is another way of connecting into all of this stuff. But right now we are not sharing much of this information we are collecting. There is a ton of it there, and it's the whole idea of sharing is, I think, one of our challenges.
Well, it seems it goes back to stakeholder engagement, which requires the transparency that generates the trust.
I can remember early on when there was this sort of digital wall between construction companies, EPCI companies, and the operator. And the EPCI companies, engineering, procurement, and commissioning companies would build these facilities, and they would be operating on the digital twin with their CAD/CAM models, and everything would be integrated. And the operator, I worked for a big operator who built these billion-dollar facilities. All was in our contract is said we needed a fax machine number. And, there was all of this rich digital information that the contractor had that the operator didn't even ask for. Well, that's changed now. And in a drilling contract, in a construction contract, whatever it is, the operator now wants to see all of that information and has built capabilities to consume it. Now I think that needs to go out to between operator and regulatory communities, and then between the operator and the community itself, so that concerned citizens, interested citizens can take a look at what's going on in their neighborhood.
Okay, very interesting topic and interesting questions. Jim, we're going to go ahead and switch over to Morgan now and take up any remaining questions for you and for all the panelists during the panel session.